Hi, hello everyone, how are you? My dear students, all of you very good morning. Welcome to the class. Yesterday we are discussing about refraction of light. I hope that all of you understand the topic. Today we are going to learn refractive index. It is very most important topic in this lesson. All of you listen carefully and understand it. Okay, let us start the class. First of all, we are discussing about what is refractive index. First we have to learn about definition of the refractive index. Refractive index is tell us how much the speed of light reduces when it travels from one medium to another. Suppose light travels from medium 1 to medium 2. Here we have to show the picture. Let V1 is equal speed of light in medium 1. V2 is equal speed of light in medium 2. Then the refractive index of medium 2 with respect to medium 1 is N21 is equal V1 by V2. That means refractive index formula is refractive index is equal speed of light in medium 1 by speed of light in medium 2. Okay, here shown the picture. Here N21 is equal refractive index of medium 2 with respect to medium 1. V1 is equal speed of light in medium 1 and V2 is equal speed of light in medium 2. Here we have to notice one thing. If light enters a slower medium, that is V2 is less than V1, the refractive index N21 is greater than 1. Okay, I hope that understand the definition of refractive index and formula. Okay, now let us explain the refractive index. Explanation of refractive index. When light travels from one transparent medium to another, its speed changes. This change in speed causes the light to bend. The refractive index helps us to measure this change. We have to observe this diagram. Here the light ray passes through medium 1 to medium 2. Medium 1 from medium 2. Then the light ray is not enter in straight at medium from medium 1. It bends towards the normal. So the speed of the light is changed in medium 2 compared to medium 1. Okay, here how does light behave in different media? In vacuum, the light travels faster with speed c is equal 3 into 10 to the power of 8 meter per second. In air, the speed of light is almost the same as in vacuum. In water or glass, the speed of light is less than in air. Light always travels slower in optically denser media. Okay, definition is, once again the definition is recap. Suppose light travels from medium 1 to medium 2. Let V1 is equal speed of light in medium 1, V2 is equal speed of light in medium 2. Refract index of medium 2 with respect to medium 1 is N21 is equal speed of light in medium 1 by speed of light in medium 2, that equal to V1 by V2. That means the refractive index shows how many times the speed of light in medium 2 is less than its speed in medium 1. Okay, here we have to learn about absolute refractive index. If the first medium is air or vacuum, the refractive index is called absolute refractive index of the medium. Okay, that formula is given here. N is equal to C by V, where N is equal to absolute refractive index, C is equal to speed of light in vacuum, that is 3 into 10 to the power of 8 meter per second. It is constant. And V is equal to speed of light in the medium. Okay. Here show the diagram and learn this. If V2 is less than V1, that is slower medium, the ray bends towards the normal. That time refractive index is greater than 1, that is N21 is greater than 1. Okay. If V2 is greater than V1, that is faster medium, the ray bends away from the normal. Refractive index is N21 is less than 1. Okay. Here you must remember this one because it is useful to solve the problems. Okay. And key points we have what we learn in this topic. Refractive index is always a ratio of speeds. Okay. So it is ratio of speeds, that means it have no units. So it has no units. It depends on the pair of media and speed of light in them. Okay. Here we have to understand use one example. Here example is there. Speed of light in air already known, 3 into 10 to the power of 8 meter per second. Speed of light in water 2.25 into 10 to the power of 8 meter per second. Then absolute refractive index of water is, the formula is N is equal to C by V. Now we are substitute the values of speed of light in air and speed of light in water in the formula. So that substitute, then it gives 3 into 10 to the power of 8 by 2.25 into 10 to the power of 8. Both are speeds, so their units are cancelled, so it have no units. Okay. So we calculate them both values, then we get the answer is 1.33. It is completely only number, so it have no units. So we have to understand refractive index has no units. Okay. Here some key points are there. We are discussing about this. Refractive index is the ratio of speeds of light in two media. Okay. It tells us how much the speed of light changes when it enters another medium. Suppose the medium is have higher refractive index, then light travels slower. Okay. So that medium is called optically denser. Suppose the medium have lower refractive index, the light travels faster. So this medium is called optically rarer. Okay. All of you understanding explanation of the refractive index. I hope that the topic is understand you well. Now let us learn about something more. Here we have to understand more about absolute refractive index. We are already known the definition of absolute refractive index. When the first medium is air or vacuum, the refractive index of medium is called absolute refractive index. Here we have to learn in definition also. The absolute refractive index N of a medium is the ratio of the speed of the light in vacuum or air to the speed of the light in that medium. So the formula is N is equal to C by V. Here N is equal to absolute refractive index. It have no units. Okay. C is equal to speed of light in vacuum or air, that is 3 into 10 to the power of 8 meter per second. It is also constant. Next, V is equal to speed of light in the medium. Okay. The shown in the figure normal. Figure in two mediums and normal. Here suppose C is greater than V. C means air or vacuum. Okay. V means medium. Okay. C means the speed of the light in air or vacuum. V means the speed of the light in medium. So if C is greater than V, light bends towards the normal. Therefore, n value is always greater than 1. Okay. Here some explanation what we learn. Light travels fastest in vacuum. That is speed of the light, air, speed of the air. Okay. If any other transparent medium, its speed becomes less. That is V less than C. Therefore, n is equal to C by V is always greater than 1 for all transparent media. Okay. Here we have to given some example. Already we learned in previous session. Okay. So, absolute refractive index of some common materials here. Some materials are there and their refractive index are also given here in the table. Okay. If you all the refractive index are no units. Okay. Key points. The absolute refractive index has no units. It depends only on the medium at given temperature. And a large value of means light travels slower in that medium. Okay. This is about absolute refractive index. Now let us understand optically denser and optically rarer mediums. Okay. The ability of medium to refract light depends on its refractive index. A medium with higher refractive index is called optically denser. So its refractive index value is high. Okay. A medium with lower refractive index is called optically rarer. So its refractive index is lower. So which refractive index is high? That medium is called optically denser. Which refractive index has lower refractive index? That medium is called optically rarer. Okay. Here some note. Optical density is different from the mass density. Okay. For example, kerosene has higher refractive index 1.44 and is optically denser than water 1.33, although its mass density is less. Okay. The water density is less than kerosene density. Okay. So kerosene have higher refractive index and water have low refractive index. Okay. All of you understand? Now next, if the light ray passes through one medium to another medium, how to find is it optically denser or optically rarer? Now let us show the picture. Direction of bending of light. Okay. First, all of you see the picture A from optically rarer to optically denser medium. Here light bends towards the normal because the light ray passes through rarer medium to denser medium. Rarer medium from rarer medium to denser medium. So the light ray is towards the normal enter the denser medium. Okay. All of you understand? The medium of the light, the speed of the light is lower in denser medium. Okay. It is optically denser medium. Okay. Refractive index. Here refractive index is increases. So N2 is greater than N1. For example is here some rarer medium and some denser medium. Suppose air refractive index is 1 and glass refractive index is 1.52. So air is which refractive index is high? That is denser medium. So air is rarer medium, glass is denser medium. And again one more example is here. Air is equal to 1.00. That means air refractive index is 1, water refractive index is 1.33. Here is also water density, water is denser medium, air is rarer medium. Okay, optically rarer medium. Here, suppose in this case the light enter from rarer medium to denser medium. Okay, now opposite, the light ray enter from denser medium to rarer medium. In that case, the light ray is away from the normal. So the light ray enter from denser medium to rarer medium. It is away from normal. Okay. Here refractive index is low. That means N2 is less than N1. So in rarer medium the refractive index is lower. Okay. Examples are here. Glass refractive index is 1.52, air refractive index is 1. So here the light ray enter the glass from air. So its refractive index is decreased and speed of the light is increased. So the refractive index is inversely proportional to speed of the light. Next example, water. Water's refractive index is 1.33, air refractive index is 1. Here is also the refractive index of water is less than air, refractive index of air. Here we have to understand more effectively using this table, comparison of media. Here in this table given property optically denser medium, optically rarer medium. If optically denser medium refractive index is high, if optically denser rarer medium refractive index is low, and optically denser medium speed of the light is slower, and optically denser rarer medium speed of the light is faster. In optically denser medium bending of light is towards the normal because it is rarer, comes from rarer medium. Okay. In optically rarer medium the bending of the light is away from the normal because it's from denser medium. Some examples of denser medium is water, glass, diamond. Some examples of rarer medium is air and vacuum. Here key points we have to learn in this class. If the medium have higher refractive index, it is optically denser, and in this medium light travels slower. If the medium have lower refractive index, the medium is optically rarer. In this medium light travels faster. Light always bends towards the normal when it enters a denser medium. Light always bends away from the normal when it enters a rarer medium. If there is no change in refractive index, both are same medium, light does not bend. Okay. Here some examples are here. Already we are known. Pencil in water looks bent because light goes from water, that means denser medium, to air, that is rarer medium, and bends away from normal in this first case. In the second case also, fish in water appears higher than its actual position because light goes from water, that is denser to air, rarer, and bends away from normal. In third case, lenses of spectacles are made of optically denser material, that is glass, so that light bends properly and forms clear images. Okay. These are all some examples of denser medium and rarer medium. Now a small activity to understand more effectively in this topic. Take a glass tumbler filled with water and place a pencil inside it. Now what we observe? the pencil appears bent or displaced at the water surface. Why does this happen? Light from the lower part of the pencil travels from water, optically denser, to air, optically rarer. It bends away from the normal while coming out into air. Our eyes see the light along straight lines, so the pencil appears bent. Okay, it is clearly shown in this figure how to bend, why it's bent. Okay, the light ray coming from air to water, so the water is denser, optically denser, so the light ray away towards the normal. Okay, what we learn? Light changes its speed in different media. Refractive index helps us understand the bending of light. The phenomena is called refraction. Already we learned in before classes. Conclusion. What we understand this class? In this class we learned meaning of refractive index. It shows how much the speed of light reduces in a medium. Formula of refractive index: n21 is equal to v1 by v2. That means ratios of speeds of light in two media. Absolute refractive index: n is equal to c by v. When the first medium is air or vacuum, optically denser and optically rarer medium. In the medium is higher refractive index, it is optically denser. The media have lower refractive index, it is called optically rarer. Directions of bending of light: rarer medium, rarer to denser, bends towards the normal. If the light travels denser to rarer, bends away from the normal. Okay, here refractive index is the key to understanding why light bends when it travels from one medium to another. Okay, again we have to given the medium have higher refractive index. In this medium the light slows down. If the medium have lower refractive index, in this medium the light speeds up. Okay, here we have to given some questions. When light goes from air to glass, does it bend towards or normal, away from the normal? We have to observe the figure. Here air is dense, optically rarer. Here what in water place, it in the question given glass, so glass is optically denser. So the light ray coming from air to water, it bends away from the normal or towards the normal. So it comes from air to glass, so the light ray towards the normal, because that is optically denser medium. Okay, so the answer is towards the normal. Which medium have higher refractive index, water or crown glass? In this two are compare with refractive indexes, the water refractive index is less than crown glass refractive indexes. So which what is in both water and crown glass, both are compared to which is denser and which is rarer. The crown glass is denser medium, so the denser medium, the optically denser medium have high refractive indexes, so crown glass is have higher refractive index. Here answer is crown glass. Third one, if the speed of light in a vacuum in a medium is half of its speed in vacuum, what is the absolute refractive index of the medium? Here we have to given the speed is half speed of the vacuum, so the medium speed is half. Here we have to use this formula. What is this absolute refractive index? This formula n is equal to c by v. Here in this question we have to given the speed of the medium is half. So now we substitute the formula. So the v is equal to v by 2. So we have to substitute in this formula n is equal to c by v. Okay. Now we have to calculate the refractive index c by substitute v equal to v by 2. So c by v by 2. So then it calculate 2 into c by v. But c by v is equal to n. So the refractive index is double. In this question, the speed of the light in a medium is half of its speed in vacuum. What is the absolute refractive index of the medium is double. Okay, the refractive index is 2 times. Okay, this is the questions. Now we have to remember one thing. Light always bends because its speed changes when it moves from one medium to another medium. Okay, I hope that all of my children understand this topic, refractive index, clearly. If you have any doubts, please ask in comments. Okay, I hope we are all welcome to next class, and thank you to listen my lesson today. It is very useful to you. I hope that it is very useful to you. Okay, thank you so much. We will meet in next class. Thank you.